Hello students. In this lecture, we are going to study about very essential questions based on fundamental identities and reduction formula, which we have studied so far. So without any further ado, let's get started. So have a look on the question number 1, where the value of A and B is given in terms of a trigonometric function. We need to prove that A square plus B square, it is equals to 2. So what you can do, first of all, try to deduct this sine 90 plus theta. As you know, sine 90 plus theta is equals to cosine theta. So there we go. We now have the value of A with us. Do the same thing with B. Since cosine 90 plus theta, it is equals to negative sine theta. Now, once we have the value of A and B, put the value of A and B in left hand side expression and add their squares. So A square plus B square will be equals to square of sine plus cos summation with cosine minus sine whole square. So this will give me sine square plus cosine square plus 2 sine cos on the first one. And then we have a cosine square plus sine square minus 2 sine cos. This 2 sine cos will get cancelled out and we end up getting a 2. Correct? Now let's move to the next one. In that one, we need to find the number of solution of this equation. In this equation, we have two factors in sine, and their product is equals to 0. So what may be the reason that we are getting a 0? Either 3 sine theta minus 1 should be equals to 0, or we may have the another reason for which sine theta minus 2 will give you a 0. From the first relation, we end up getting the value of sine theta, it is equals to 1 by 3. And from the second one, we are getting the value of sine theta, it is equals to 2. It is equals to 2. But we all know the boundation of sine theta. Sine can never give you a value greater than 1. So this is something which is not possible. So if it is not possible, then their product is getting equals to 0, in which your second linear factor will not participate. So the only reason this equation may have a solution will be will get from sine theta equals to 1 by 3. Now, how many thetas will exist for which sine theta is responsible for 1 by 3? You may use the graph a bit, or just for the clarification or for a detailed explanation. See, this is the graph of sine theta from 0 to pi. 0 and pi both are excluded as given in the question. Now we need to draw the graph of y equals to 1 by 3. So let me say this is the graph of y equals to 1 by 3, and we need to check at what are the points or how many points are there where both the graph are getting intersected. You would say it is 2. And in fact, we already know the answer. Sine is positive in quadrant number 1 and quadrant number 2. So definitely we'll get a solution in first quadrant and another solution from quadrant number 2. So how many solution of this equation exists? It is 2. If you are considering one of the angle or one of the theta is alpha, then definitely another angle will be pi minus alpha. Now let me move to the next one. In this one, it is given that 2 to the power n is equals to cosecant 5 pi by 6. Do you know the value of cosecant 5 pi by 6? If you don't, then you may use the reduction formula, where you need to find the very close multiple of pi by 2 near 5 pi by 6. It is pi, so you may represent 5 pi by 6 as cosecant pi minus pi by 6. Now, do you know what cosecant pi minus theta stand for? It is cosecant theta. It is cosecant pi by 6. Since we know cosecant is reciprocal of a sine, so the value of cosecant pi by 6 is actually a 2. Now, if the base are equal, you may establish a relation in its index. There we go. Now have a look on the second one. Isn't it look like the same question which we have already done, the previous one, where we are looking for the number of solution for which sine theta is equals to 1 by 3. There we need to find the possible solution in the range from 0 to 2 pi. But we know sine is positive in quadrant number 1 and quadrant number 2. So the only solution which will obtain is from quadrant number 3 as well as from quadrant number 4. So there you go. If you like to draw the graph of sine x from 0 to 2 pi, there we go. And we need to draw the another graph for y is equals to minus 1 by 2. So say this is the graph of y equals to minus 1 by 2. These two graphs are actually intersecting at 2 points. So we have two different possibility. One from coordinate number 3 and another from coordinate number 4. So what trigonometric deduction you would use to establish a relation in coordinate number 3 and coordinate number 4 with coordinate number 1 obviously. In coordinate number 3 we usually say, or we usually prefer sine 180 plus theta. Do you know the result of sine 180 plus theta? Yes, it is negative sine theta. Now put the value of theta in such a manner there that you end up getting the magnitude of the function equals to 1 by 2. So if you substitute your theta with the pi by 6, you will have the result. So there you go. We have the one solution. Sine 210 will give you the same result as of negative cosine 30. What negative cosine 30 stand for? It is negative 1 by 2. This is for from coordinate number 3. Now half of the work is still yet to be done. From coordinate number 4, what relation we can use? In coordinate number 4, we usually prefer sine 360 minus theta, and we know what 360 minus theta stand for in sine. It will again give you negative sine theta. Do the same thing again, put the value of theta there and you will have the result. And this is the result. So what two angles are there? One is 210 and another one is 330, which will give you the value equals to negative 1 by 2. Now let me take the another one. And that one, if cosecant theta is equals to minus 1, then number of solution of this equation. Do try this question. And if you are able to solve, then please do let me know. Let's move to the next one. Question number 2. It is given that sine theta plus cosine theta is equals to 0. And since theta lies in the fourth quadrant, then what will be the value of theta? What sine theta plus cos theta equals to 0 stand for? You may write sine theta should be equals to negative cosine theta, isn't it? By shifting your cosecant to the other side. Now, once you divide your expression by cosecant theta by assuming that you will not be entertaining the value of cosine equals to 0. So once you divide this expression with the cosine theta, you end up getting the value of tan theta, and it is equals to negative 1. Tan is negative in coordinate number 1 and in coordinate number 2, in coordinate number 4, excuse me. Now, do you know any value of theta which is responsible for value 1? If I'm talking about magnitude wise, you would say yes, it is theta equals to pi by 4. Now we need to get this angle in from quadrant number 4. So your 360 minus theta will give you that opportunity to get the value of tangent in quadrant number 4. Since tan 360 minus theta, it is equals to negative tan theta due to its position in quadrant number 4. Now, the moment you substitute theta with a 45 degree, you end up getting the value of that corresponding theta in quadrant number 4. And it is nothing but 315 degree. So your tan 315 degree will give you the result equals to negative 1. Now, let me take the one more. Cosecant 1 radian minus sine 1 radian. You need to tell me whether this inequality is true or false. For that one, you should be aware with the approx value of 1 radian. Since the value of 1 radian is very approx to 57 degree or close to 60 degree. Now let me draw the graph of sine theta and cosine theta parallelly. We know that theta is equals to pi by 4 is that point where sine and cosine will give you the same response. Before pi by 4 and greater than 0, your cosine will having a greater value than sine. But 57 degree will be what? It will be greater than 45 degree. So it will lie somewhere there. So if this is your 1 radian, now you may compare their outputs corresponding to their graph. Since near for 57 degree, your sine is greater than the cosine function. So what actually should be your relation be? What should be your relation? Your value of sine 1 radian should be greater than the value of cosine 1 radian. So this will make the statement false. Let me take the another one for a great insight. There we need to get the sine of sine 140 degree plus cosine 140 degree. If you don't feel comfort in 140 degree, do your reduction, use your deduction formula where you may write your 140 degree as a 180 minus 40 degree, and do the same with the cosine 140 180, excuse me, minus 40 degree. Now what 180 minus theta reduction stand for in sine, so this will give you sine theta. We have sine 40 degree, and from the second one we have negative cosine 40 degree, negative cosine 40 degree. Sine 40 degrees positive value, and as well as your cosine 40. Now we are still in the dilemma, the sign regarding the sign of this function, sign of this expression. Now 40 degrees slightly lesser than 45 degrees, so we will be somewhere there the line. So if this is, let me mark, if this is your 40 degree, at 40 degree your cosine will give you greater output than sine. So we'll have this relation. According to the graph, cosine 40 degree will be greater than sine 40 degree, sine 40 degree. So this expression should be what? This expression should be negative. I hope this question will help you out a lot in your preparation. Thank you very much.